This is section 6.2.2, solving linear equations with fractions. We start with a review of the properties of equality. We sort of introduced these in the last lesson. They are the addition property, the subtraction property, the multiplication property, and the division property. These properties allow us to add, subtract, multiply, or divide by numbers or variables to both sides of an equation without changing the solution set. These are basically your tools for solving equations. All right, in today's lesson, we're going to solve equations same way we did in the last lesson, except now, as you can see, our equations have fractions in them. And a lot of students don't like working with fractions. I don't like working with fractions. So the first thing we're going to do in each case is we're going to eliminate the fractions, right? And that's really the key step. So let's take a look at each example one by one. So in our first example, x over 3 plus x over 2 equals 5/6. Now, in order to eliminate the fractions, we need to come up with a common denominator. So notice our denominators, 3, 2, and 6. You need to think to yourself, what is the common denominator? The least common multiple would be the best scenario for these three numbers. And remember, we studied that earlier in the year. Now, hopefully you're thinking to yourself, oh, 3, 2, and 6 all go into 6. So what we're going to do is we're going to multiply both sides of the equation by 6. And we are allowed to do this because of the multiplication property of equality. Now, on the left side, over here, we have to distribute the 6 to both terms in the parentheses. So let's do that. Notice I have 6 times the first term, 6 times the second term, right? So let's actually do the multiplication here. And what do we come up with? 2x plus 3x on the left side. Of course, 6 divided by 3, which you see right here, is 2. And 6 divided by 2, which you see there, is 3. So that's where those numbers are coming from. And the nice thing is, our fractions are gone. 2x plus 3x equals 5. Of course, over here, 6 over 6 is 1, right? 5 times 1 is 5. So there we go. So let's combine like terms on the left. 2x plus 3x is 5x. Now we divide both sides of the equation by 5 in order to isolate the x, and we end up with x equals 1 for an answer. Here's our second example. So again, our denominators are 5, 1, 10, and 2. So what is the least common multiple of these numbers? Well, hopefully you're thinking to yourself, all these numbers go into 10. All right, so what are we going to do? We're going to multiply both sides of the equation by 10. And of course, we have to distribute here to here. And we're going to have to distribute on this side too, because there are now 2 terms on the right side of this equation as well. So let's go ahead and do that distribution. There it is. Notice that when we distributed on the left side, we had to distribute to this term as well, right? And that's what gives us that negative 10x right there. All right. 5 goes into 10 twice. 2 times 3x is 6x. We bring down our negative 10x right there. 10s will cancel there, leaving us with that x. And 2 goes into 10 5 times. 5 times 5 is 25. Of course, we have this minus sign right there too. All right, so keeping track of all our arithmetic there, we end up with 6x minus 10x equals x minus 25. Now we can start to simplify the 2 sides of the equation. So on the left side, 6x minus 10x gives us negative 4x. Of course, we have this x that we need to move over to this side and combine with that x. So what we're going to do is we're going to subtract x from both sides. When we subtract x from the right side, it's gone. When we subtract x from the left side, negative 4x minus x is negative 5x. So we see that happening. And then finally, we're going to divide both sides of this equation by negative 5. By negative 5, right? Negative 5, negative 5. Right? The negative 5's cancel out, leaving us with positive x. And negative 25 divided by negative 5 on the right side leaves us with positive 5. Next example, 2x over 3 plus x over 7 equals 1/6. So common denominator of 3, 7, and 6. Well, what are you thinking? Are you thinking maybe 42? All those numbers go into 42? Yep, there you go. And it's important to note that you don't have to come up with the least common denominator or the least common multiple. It just needs to be a common multiple. All right, so we're going to have to distribute here on the left. No distribution on the right, but of course we'll have to simplify that. So let's do it. We distribute. 3 goes into 42, 3 goes into 4 once with 1 left over, making that a 12. 3 goes into 12 4 times. So 14 times 2x we would end up doing. 7 goes into 42 6 times x. 6 goes into 42 7 times 1. We can simplify all of that. 28x plus 6x equals 7. Combine like terms on the left side. 34x equals 7. Divide both sides of that equation by 34, and we get x equals 7 over 34. And next we have m over 2 minus 5m plus 5m over 6 equals negative 4. All right, so let's look at our denominators. Obviously 2. Here we can think of that as being over 1, 6, and of course here over 1. So really we're just working with the 2 and the 6. Common denominator of 2 and 6 is 6. So let's multiply both sides of the equation by 6. Now we're going to have to distribute 1, 2, 3 different terms in parentheses. All right, so let's do that. All right, now I haven't shown the steps like I did before because I'm doing them one at a time. 2 goes into 6 3 times. 3 times m gives us that 3m right there. All right. Of course, here we had a 1, so 6 times negative 5m gives us our negative 30m. And then 6 goes into 6, 1 times 5m gives us the positive 5m. So there you go. And on the right side, negative 4 times 6 is negative 24. All right, let's start to combine like terms. You can see all of these are m terms, so let's combine them. And we get negative 22m equals negative 24. Divide both sides of the equation by negative 22. And remember that a negative divided by a negative is a positive, so that's why, okay, if we divided this by negative 22, a negative divided by a negative is a positive. That's why both of these are positive now. All right, and of course 24 over 22 can be reduced because 2 goes into both of them. We end up with 12/11. All right, so those are some examples of equations that have fractions in them. As I said, use the properties of equality as your tools to solve. And the first thing that you want to do is eliminate the fractions by multiplying through by the common denominator. This has been section 6.2.2, solving linear equations with fractions.